Hey everyone, it's Patrick. Thanks, Chad, for covering for me as I got my computer rebooted here. Thanks everyone for joining our April 8th, 2021 meetup. Assuming everyone can see my screen, but if and it's got basically a deck up on it, but if you can't, I'm sure someone will let me know.
Yeah, I can see it.
Perfect. Thanks, Chad. All right, great. So virtual. This is our fifth virtual meetup in about 9 months of virtual meetups. So we're kind of finally at that pace where we're sort of able to meet every month or every 6 weeks, which is great. We've got two more meetups lined up here. One coming up in May, and then one coming up in June. So as always, we're open to ideas on how we can improve the content and the format. So future meetups, anything anyone in the community would like to present, any topics that they'd like to see covered, or even formats, right? We've sort of fallen into the format of kind of a single presentation, but anyone that wants to put forth ideas, lightning talks, mini sessions, we're always open to hear that. You can engage with us on our meetup pages, as well as our community Slack. And as always, we post both the recording of the session and the slides themselves on SlideShare. So with that said, let's go ahead and get started. So today we're going to talk a little bit about security on AWS. More specifically, we're going to talk about some of the more recent AWS services over the past few years, right, that have been added that help organizations increase and enhance their security posture on AWS. And we're going to relate them to some common frameworks, more specifically the NIST cybersecurity framework. As a reference use case or reference architecture, we're going to look at a typical end user computing scenario. We'll talk a little bit more about what that entails. And using that end user computing scenario, we're going to talk about incident response as it relates to responding to a ransomware event. So why is this important? Well, according to Verizon in their 2020 data breach investigations report, the number of breaches has increased. But with that, the discovery and containment time has continued to decrease year over year. Why is that? Well, it's really the introduction of approaches or frameworks like the cybersecurity framework, as well as services that aid in both the detection, containment, and response to these events. Alongside that, public cloud adoption is growing with no end in sight to that growth. Year over year, it's forecasted to increase. Even more challenging, though, the workloads running in cloud continue to be varied, right? There's workloads that may be migrated from other places. They may even be migrated and optimized. They may be purpose-built on the cloud, leveraging serverless or native capabilities. They may be highly orchestrated using solutions like Kubernetes. They could even be hybrid solutions that spread across multiple clouds, multiple data centers.
If I could interrupt for just a moment, we're still seeing the title slide.
You are? Okay, thanks. Appreciate that. Yeah, I'll go ahead here and stop sharing. That was weird. I wonder why. I'm going to reshare it here in a second. Okay, you should see something that is not the title slide now, right?
Yes, customer workload personas.
Perfect. Yeah, and then you should see it flip back and forth here, I think. Yeah.
Yeah, we see it.
Yeah, it's
flipping.
working now.
Cool.
Yeah.
Thanks. Yeah, that important distinction in between sharing out a window and sharing out a screen. So, all right, we got that under control. So I won't make you guys sit through those slides again. So as these personas have grown, and thanks for letting me know, so has the variety of services available on AWS. Here's just kind of a snippet of the high-level categories. And on top of that, right, with cloud, with public cloud, with many public cloud providers, including AWS, there's sort of a shared responsibility model, right? AWS inherently in the services provided, particularly infrastructure up, there are responsibilities that you as a customer are going to have, right? There are responsibilities that AWS is going to have. AWS is going to handle a lot of the physical security stuff, right? AWS is going to handle the security of the sort of the hypervisor or the abstraction layer, right? You as a customer, right? You own that data, right? You own those configurations. You make those service selections, right? Whether or not to encrypt, how you administer users, right? So there'll always be the shared responsibility model. It is very well defined, right? Particularly when you look at mapping or aligning to certain frameworks, right? In AWS Artifact, you could see how, on a service-by-service basis, your responsibility as a customer versus AWS's responsibility as sort of the provider are aligned. So we'll talk a little bit about our scenario, right? So as I was putting this together, I was trying to think, what is a common scenario that we can illustrate, right? So, I thought to myself, workspaces is a great scenario to use to illustrate some of the out of the box, right, default security controls that as a service AWS provides, but then as a customer of AWS that you need to be aware of and are ultimately responsible for implementing, right? So for those that are not familiar, Amazon Workspaces is essentially a managed virtual desktop environment, right? AWS essentially provides the orchestration of the spin up, the spin down, what is effectively a virtual machine, an EC2 instance, and allotment to named users, a client by which those users can connect and access their virtual desktop. Again, think something like remote desktop services, something like X Windows, and effectively work it and use it like they were using a desktop, right? So in the shared model here, AWS is effectively responsible for the top segment of this orange box. Your red building, your blue building, your auth and session gateway, and your streaming gateway, right? These are internet-based endpoints that the client is connecting to. AWS has implemented various security controls around encryption in flight, protecting that through TLS or SSL, as well as managing things like brute force attempts to log in, denial of service attacks, and so forth. As the customer or user, the bottom part and the left data center part becomes your responsibility, right? How you allot and assign your users to use this service, so the authentication, as well as sort of the protection of traffic entering or leaving those workspaces through your private network, and even what happens on those machines themselves. Again, it's a virtual desktop environment that you, as an administrator of these, have full access to. You may opt or not opt to give your customers that same level, or your end users that same level of access. So what's missing, right? So that this is an out-of-the-box service. It provides a lot of great capability and functionality. But again, you as the customer, you're responsible for the ingress and egress traffic coming into those workspaces, right? And the workspace's access to the internet. You could turn it on, you could turn it off, you can even filter it, right? If you're running multiple services, if you're tightly integrated into other data center environments through a VPN tunnel, through a private point-to-point connection, right? You're responsible for the east-west traffic flow. As mentioned, the workspace environment itself, endpoint security, right? Running anti-malware, ensuring users don't click naughty links, etc. And then the supporting servers, right? The authentication servers, right? You can choose to leverage a managed service that manages these for you, something like Managed Active Directory. You could choose to roll your own virtual machines. You could even integrate that on premises. You may have other network resources that are available from these workspaces, again, running in AWS or running on premises. Client server applications, web applications, and the like. I just got to note that you can only see my title pages. Is that correct? Or are you guys seeing these slides, the slides change?
I'm seeing what's missing.
Okay, perfect. Thanks, Chris. User permissions, right? Whether the user is a local admin, global admin, regular user. Access, right? Restricting. These workspaces should only be accessible from this machine by this user from this IP space. And then let's not forget, right? This is a service running in an AWS account. There's sort of baseline things that you as a customer of AWS will want to implement, right? And that's where we're going to really focus this conversation, the rest of the AWS account piece. So back to the sample deployment, right? When we look at a out-of-the-box deployment, inherently secure from the internet, right? Again, users must authenticate to access their workspaces. Traffic is encrypted. The two blue and green gateways are protected. Everything else, right? And of course, all the physical layer stuff, the data centers, the hypervisor, the orchestration, the consoles, the APIs, right? All sort of protected, secured by AWS. Again, you as the user, responsible for what happens in that virtual network, what happens in that data center. Your hypothetical customer CorpNet on-premise data center there in the bottom left. So when we look at real-world scenarios, right? Where are our potential weak spots, right? So common misconfigurations or common overlooked things when deploying a workspaces, right? By default, security groups, right, which is essentially your stateful context-based firewall, are going to block workspaces to workspaces traffic. That is good. When you look at sort of the propagation of ransomware, that is one of the ways that they will propagate that not having that blocked or dropped traffic, right? So in some cases, customers, for convenience sake, may opt to open those ports up. That is not a default behavior. That will effectively help spread, right, malware. Now, question is how is that introduced into the environment? Well, the workspaces itself can be configured to allow or not allow outbound traffic to the internet. More so, it could be even configured to route out the internet of, say, your on-premise data center. Or, as AWS has very recently introduced, you could actually route it through almost a layer 4 through 7 style firewall, AWS managed firewall, where you can explicitly allow or disallow access to certain IPs, host names, FQDNs, and the like. You could also bring your own third-party next-generation firewalls and do further content filtering, right? So this is the first place, right? How do we actually prevent the introduction of the malware into the environment? It's going to be here. It's how do we restrict users from inadvertently clicking and downloading traffic, content from the internet. So question about the DMZ, right? So with the workspaces model, effectively the AWS managed part would be considered your DMZ, right? That's the part in which traffic can sort of come in, client traffic only come in through the internet, right? That's very specific ports, trusted, TLS protected, authenticated. So let's assume, right, that step's been missed. The securing end user access out to the internet. I open a browser, I download something, and here we go, right? Defense in depth, right? So in my workspaces environment, well configured, I would essentially be running a piece of anti-malware software, right? Some workspaces bundles will even include Trend Micro Office Scan, right? So nearly out of the box, capabilities to assuming that something was introduced into that virtual desktop, that it would be detected and of course contained. So let's say that didn't happen, right? So now it's able to spread, and perhaps it's able to make its way into other servers. Again, if by default, right, all that traffic is sort of blocked and dropped. If that has been opened up inadvertently, mistakenly, intentionally, whatever it may be, we start to see that spread. So this is where local user permissions will play a role, right? So it's sort of a good practice that we try to extend to customers is leveraging really a 3-tier model for users. Local users, right? Standard users have just that user level permissions. Power users potentially with local admin permissions. For actual global admins, so think like an Active Directory domain admin, we actually encourage the use of separate identified admin accounts, right? So if I, John Smith, as an admin of my Active Directory in my day-to-day, I use my John Smith user. In my administration of Active Directory stuff, I basically use a separate user that has those privileges. This way, as in my role as a regular user, if I inadvertently or accidentally download a piece of malware, it is not able to use my privileged credentials in order to further propagate itself through other systems, right? And then finally, right, more of a concern around what if my actual user credentials are compromised through some other means? What is to keep someone from actually logging into my workspaces? So there's 4 distinct controls available in workspaces that help manage this. You can effectively have your client machine explicitly trusted by workspaces, meaning you could only connect from that machine. Most recently, December, AWS introduced support for smart cards, PIV cards, right? So as a sort of additional factor in addition to my username and password, I must actually have inserted my PIV card and entered my PIN to unlock my personal certificate. Also supported is source IP address filtering, and then finally multi-factor, which is by far the most often encountered scenario. So effectively, one-time use code required in addition to your username and password to log in, right? So this sort of blocks that stuff at the front door. But finally, we still have the rest of the AWS account, right? And so this is sort of where the investigation work begins, right? So let's say in an environment where some of these best practices haven't been applied, and essentially there's been a situation where malware was introduced. Being able to actually perform investigative actions and understand how it occurred, if it's currently happening, and make informed decisions on what next steps to take are key. And there's a number of AWS services that are going to help address that. So let's talk a little bit about the approach. So the NIST cybersecurity framework is essentially a high-level framework that contains essentially a number of milestones utilized with guidance on how you can assess and improve your ability to prevent, detect, and respond to cyber attacks. And so what I've done here in some of these slides, I've sort of aligned it to that exact flow, right? So identification and being the first step, and the AWS services that are going to support that. Prevention, detection, response, and so on. So the other cool thing is, especially if you're running a hybrid environment, there are a number of AWS services that you can actually extend into your data center. Monitoring from a CloudWatch perspective, sort of patch management from a systems manager perspective. A lot of those services can be extended to servers within your data center. So you're not only protecting your resources in AWS, you're actually using AWS to protect the resources outside of it. There's also a number of complementary frameworks and controls, almost to the point of confusing, but each sort of plays their own unique role on where an organization is in their adoption of cloud. So the NIST cybersecurity framework basically has 5 phases: the identification, protection, detection, response, and recovery. So identification is effectively a level of maturity within your organization to identify and manage cybersecurity risks to systems, people, assets, data, and capabilities. It starts with inventorying, or can start with inventory, right? And education, right? With identifying your systems, your services, your workloads, you can develop policies, processes, procedures that help drive really the next steps. That's the protection, right? What safeguards have you put in place to protect yourself? A firewall would be a good example of this. Counter to that, a firewall is also a good example of detection, right? Because it can allow you to detect that a security event has occurred. It could even help you respond, right? Modification of firewall rules allow you to drop the traffic you've identified potentially. Or even recover, right? Where we'll talk a little bit about the steps taken once you've responded and contained the event, how you actually get back to normal operations. So counter to that, right? Center for Internet Security, CIS controls and benchmarks are more prescriptive in nature, right? NIST cybersecurity framework tends to be a little more high level, procedural based. Controls and benchmarks by CIS are very, very prescriptive. Step by step, here's the recommendations, based on the controls that you should apply to specific technologies. So there's what are called benchmarks, right? And these are step-by-step guidelines for applying those controls to specific technologies, as I just said, sorry. Great news here is there are ones that are out there for AWS, for workspaces, Windows and Linux, and over 100 other services. Here's an example of just one control, right? So here's the CIS benchmark for end user computing. And like we talked about on a previous slide, right? Ensure administrators of workspaces are defined using IAM. right? So here's a very prescriptive guideline recommending that you create IAM users that have the ability to manage workspaces, right? So rather than say leveraging the root account, rather than say leveraging more generically scoped users in terms of permissions, this is basically making a recommendation that specific user permissions be applied for the administration of workspaces. So there's well over 100 different controls provided as guidelines and guidance by CIS in this benchmark just for implementation of end user computing services like workspaces. So it's really good low-level technical detail that you can follow step by step in sort of securing these types of workloads. There's also a concept of effectively cloud workload lifecycle management, right? And the idea here is for a given workload, you're going to select the appropriate architecture, the appropriate monitoring, the appropriate automation and processes, right? So in our example, right, above with workspaces, workload and architecture is going to drive our service selection. So my workload is I need to be able to support my users remotely, right? Probably something we're all quite familiar with. So as part of my selection, I may look at what is available, right? AWS has what I'd call a well-managed virtual desktop environment service, workspaces that we've been talking about. There are other VDI solutions out there in the space, marketplace, right? VMware's got one, Citrix has one, Microsoft has one, and so on. So you could choose to actually run all those in AWS, right? As virtual machines, as EC2 instances. What you effectively do though, right, is you move the slider, right, from sort of managed and abstracted all the way to the right here, functions and services, if you will, over to virtual machines. Now, granted, with the workspaces scenario, they are virtual machines. However, again, the orchestration, the instrumentation, the endpoints, those are all sort of managed services by AWS. So when I look at though, when I look, right, so as I'm building, selecting the services to support a particular workload on AWS, I always think about, this tweet that I saw last year, right? So there's thousands, right? Tens of thousands, hundreds of thousands of platforms and services and such that you could run, right? On a machine, on a server, a VM, an EC2 instance, right? But where again, that slider of abstraction and management, right, becomes the more I build and run, right, on a VM, on EC2, the more integration I have to do, right? So this tweet really spoke to me because as you're running more and more things on VMs, especially stuff that may be otherwise offered as a managed service, your debt along the lines of integration, monitoring, processes, and automation increase. So this is really where the automation and processes are going to drive the lifecycle management selection. So what's that mean, right? So AWS has a number of complementary services to one another that can effectively go from the organization level, right, the enterprise level, down to the specific workload, just in the management and vending side of things, right? So as an organization, I want to vend out AWS accounts to multiple teams, departments, and users. I can manage that all through organizations. I can lay down defaults leveraging Control Tower. I could even vend out specific patterns of workloads through Service Catalog, which lets me take pre-built templates, CloudFormation templates, publish them out to certain users, groups, or roles so that they could basically spin up workloads without necessarily having to get into a complex, ask with, the technology team. And with that, there's sort of this function, this concept of ephemeral compute, right? In the cases, right, where I may have a workload that isn't necessarily a good fit for an abstracted service, isn't necessarily a good fit for serverless or even containers, right? I want to still push to make it as ephemeral as possible, meaning it is able to auto recover on its own. We can leverage things like auto scaling groups. It makes the lifecycle management a bit easier. It makes patching a bit easier, and more so when we get to the recovery phase of the cybersecurity framework, it makes recovery so much easier because I literally just kill the node and let it replace itself. And along those lines, right, when we think about the less things running on servers that we have to care and feed for, the less difficult the execution of these types of processes are. This is maybe a typical set of processes an organization is going to have to go through on a workload on a quarterly or annual basis, right? Patching, right? Some very significant Active Directory hot fixes released in the past actually last month. Backup and restore testing, failover testing, credential rotation, right? All my service accounts. And then the various type of event, incident, security vulnerability and penetration testing exercises you go through for your more regulated type workloads. And of course, ongoing performance and cost, right? How's my spend and what I'm getting out of it? What can I do to do better? So the more we move towards abstracted workloads, the easier and more consistently we are able to execute these types of processes. So sort of onto the first phase, the identify phase. So identification begins with organizational enablement. And for larger organizations, AWS has the cloud adoption framework. And it basically consists of 6 different perspectives from the business, the people, governance, platform, security operations side, right? So let's just drill a bit here into the security perspective. And we do have a quick question here. So avoid pivoting within the VDI security group. So effectively, right, each VM is assigned to a specific user. And by default, the security group, the stateful firewall that they're applied to does not allow that, right? That's a rule that customers may incorrectly add that will then allow it, but by default, that's denied, that's blocked or dropped. So the security perspective, right? You're gonna recognize some very similar terminology here as we look at the cybersecurity framework. That's not a coincidence, right? The two frameworks, CFSF and CAF, are aligned in this sense, right? So it gets very detailed, right, into specifically who owns the accounts, how do you get in contact with them, what are you doing from a change and asset management perspective, what are you doing to administer least privilege access, and so on through the life cycle. So that's organization-wide, right? So very 10,000-foot view, if you will, very macro level, if you will, right? If we get down to more of the finite level or the micro level, we have the well-architected framework. So whereas the CAF is looking at it from the organization perspective, this is really looking at it from the workload perspective outward. So here we have a series of pillars which contain both design principles and best practices, general design principles, and then lenses for very specific workloads. The idea here is this is something you trigger at the commissioning of a new workload, right? So maybe I have a new workspaces deployment I'm doing. I may go through this to help me ensure that I am prepared to be able to support it. Maybe I go through a significant change in how I've architected or built a certain workload or application. I go through this again. So these are our 5 pillars. Again, a lot of similarity. How do I operate this workload? How do I secure it? How do I manage the reliability of it? The performance, efficiency of it, and the cost optimization. There's also lenses, and I've just realized that I'm missing a few here that were added. But again, a lens is going to focus on very specific workloads and recommendations around those. As an example, if I'm building a serverless application, there will be specific recommendations in this well-architected lens around how I may implement a serverless design pattern. An example that sticks out to me is API Gateway allows you to directly call AWS services. So performing simple CRUD operations on a DynamoDB doesn't necessarily need to have a Lambda function between the API Gateway and the Dynamo table. So general design patterns, right? A lot of the common operational things here. The one that really sticks out, right? Solid lesson learned here is improve through game days. What's a game day? Well, a game day has gone through a number of different terminology changes, I'd say, in my career. Sometimes referred to as a tabletop exercise. It's effectively a simulation, right? I want to simulate a certain event and identify how I, my team, my organization may react to it. It starts with preparing. What are we actually going to test during the game day? Do we have everything in place we need to be able to do it? The knowledge, the training, the processes, the people. And then we define it, right? Is basically planning an event. What's the workload we're going to game day against? Who needs to be involved? What's the scenario? Here, pertinent to tonight's topic, right? A game day about incident response, right? So the scenario is a piece of malware has found itself within the network. How do we respond? We pick our workload, personnel, environment, and the schedule, right? What day? How long do we want this to run? And then we execute your typical start, middle, end. Now, most importantly, right? We've gone through this game day process. What did we learn out of it? What do we need to change about our processes, right? What do we need to change about our architecture or training or any of those components to that scenario in order to improve for the next game day or the next actual event? So onto the security pillar of the well-architected framework, right? There's design principles and best practices. These are really focused on identity foundations, right? Identity access management. So are we appropriately leveraging non-shared accounts, right, for individual users? Are we appropriately leveraging IAM roles as an example when it comes to service communication rather than static credentials? Are we able to, for a given action, be able to identify all the way down to the API call made, the context around it? We talked a little bit about security in layers or security at all layers or defense in depth, right? So in our workspaces scenario, right, appropriate use of host-based security, appropriate use of security groups, egress filtering to the internet. How do we protect data, right? Encryption at rest and in transit, automate response and best practices, keep people away from data, right? So appropriate use of, say Active Directory permissions, and prepare for security events, right? Our game days. So on to identify, right? So this is the start, right? So we've hypothetically prepared our organization for a workload. We've evaluated that workload. So now the tangibles, right? The AWS services that help us with the identification. So most recently, and at the top here is Audit Manager. So Audit Manager is a really cool AWS service that could actually help you prepare for audits, things like PCI, things like SOC 2, or even applying, frameworks. NIST 853 for like, more public sector defense was added, I want to say yesterday, right? So the way Audit Manager works here is for the controls in a given framework, it can actually evaluate the application of those controls with specific AWS services, right? So most security frameworks are probably going to have something about the use of encryption at rest, right? So it will look at, say, EC2 instances, EBS volumes, use of KMS. It will allow you to basically attest to it, right? And then generate the evidence that then you could supply during your audit process. So kind of moving down the list, right? A certificate manager allows you to basically manage an inventory of your certificates, right? So it goes in the identified bucket. Same for really key management and secrets manager, directory service from a user management perspective, a firewall manager, right, from a sort of a WAF and security group perspective. Macy from an indexing content on S3 that may contain PII or PHI. And then you have kind of your more ops focused tools, right? So inspector, right? What vulnerabilities am I running, or what vulnerabilities exist either within the services I've configured or on my virtual machines themselves. Trusted advisor and PhD, which are going to identify things proactively. Then security hub config roles, which are going to basically do the same, but at a lower service level type basis. A lot of these services are also well aligned to the use of AWS organizations, right? So we talk about an enterprise adopting AWS that is taking a multi-account approach. You can centrally manage things like CloudTrail, ingest or deploy config roles, support a single sign-on scheme integrated to another SAML provider, directory service, or built-in. Centrally deploy CloudFormation templates through stack sets or set policies around tagging or backup. So that's identify, right? So identify, right? A little bit confusing, but identify is all about preparing. What do you have out there? Do I have everything I need in place to be able to support it? Sort of that upfront work. Onto protection and detection, right? These two really go hand in hand, right? So from a protection perspective, we have security groups or NACLs, right? That's going to protect our private VPC originated or destined traffic. We have both the network firewall and the DNS firewall, right? This works at a little bit of a higher layer than security groups. So we can basically filter by destination, host names, right? Lists of known hosts, etc. And even gateway load balancer, where I could bring third-party appliances in to AWS to monitor, manage, and filter my traffic for me. Conversely, we have WAF, which operates at kind of the highest layer, right, for ingress traffic coming through load balancer, CloudFront, and the like. And then through a combination of services, right, CloudFront, ELB or ALB, auto-scaling, right, dynamically provisioning more resources for your VM or compute-based workloads, And then Shield, we get full end-to-end, DOS or DDoS protection, right? We have protection of data at rest, right, through KMS, which is basically a FIPS 142 certified cryptographic module that integrates with many AWS services, EBS, S3, etc. ACM, which allows us to basically issue and manage both public and private certificates for encryption of data at flight. We have three forms of secure credential storage, right? Secrets Manager and System Manager. And then more recently, and pretty exciting, Nitro Enclaves. This actually works with KMS. So in cases where you effectively want to protect access to private keys, right, stored in KMS, you can effectively create an enclave adjacent to your EC2 instance. It has no inbound or outbound traffic. It effectively runs a signed container. And there is an out-of-the-box integration for Nginx that will effectively allow Nginx to consume a private key through Nitro Enclaves without necessarily exposing that key to the file system like you typically would have to do. So it's extremely powerful in not just the protection of the data at flight or data in flight, but actually protecting the key itself while it may be used on a system that you otherwise can't protect. So more on the protection side, right? So to the concept of managing VMs as if they were ephemeral workers, right? Code commit and ECS, right, allow you to securely store your apps and your artifacts. ECS now has built-in image scanning, right? So it could scan for non-vulnerabilities. And Lambda allows you to even sign functions, right? So between that and then Code Deploy or Systems Manager, you have both a secure storage of your application code and artifacts and a way to deploy it without having to touch the OS. If you take a hands-off approach to managing your VMs, that means you've minimized touch points, access, and therefore have minimized both the likelihood for introduction of error as well as the potential risk in compromise. EC2 Systems Manager similarly allows a lot of hands-off access to systems through a variety of ways. And most recently, Amazon Linux 2 has added live patching, so you can actually patch the kernel without rebooting. So backup is a huge one here, right? So running ephemeral systems, right, that you could basically shoot and have them redeploy from known good sources is the start of the recovery, which we'll talk about. Backups are another key one here, right? So as well as using secure storage like S3 or Glacier, where you can version, right, protect against intentional or unintentional deletes. We engaged with a company in December who had inadvertently exposed some credentials to the internet and subsequently found that their S3 buckets were deleted, right? Basically, username and password on the internet, that's going to happen. So because they had actually turned on versioning, we were able to help them recover those, right? Because the version will capture those deletes. Now, an additional control they could have added here would have been secure delete, right? Effectively requiring an MFA token to delete, or even leveraging something like policies to prevent deletion, or even vault lock, right? Where you can actually block deletions for a certain period of time, more of a regulatory retention requirement. So that's protection, right? So these are the services that we've laid down to protect our workload, right? Host-based security, common policies around how we're deploying and managing systems, data at rest, data in flight encryption, and of course, protection at both the traffic and the auth layer. So detect. So how do we actually know something's gone wrong? This is key, right? How we respond to, a security event, that we've detected, in hours versus a security event that's been going on for months changes the approach, right? So favorite picture of mine, knowing if you're, this is supposed to be a server, it looks like a desktop case was being used as a barbecue pit. So guard duty. Guard duty is effectively going to look at our internal network traffic, our VPC traffic. It's going to look at our DNS resolver requests. It's going to look at S3 bucket access, and it's going to tell us about known issues, right? It's categorically going to provide a severity, right? Around things like access key exfiltration, brute force attacks against common administration ports such as SSH or RDP and the like. So we start there, right? That's the detection. Config, we could detect changes to configurations. We can diff them over a timeline. CloudTrail, another huge one, right? Because this is an actual audit trail of the things going on in the environment. From a programmatic API perspective, right? So if something, say like a security group change was made, we can actually detect that. And flow logs. This is going to be key, right? We want to understand, once we've detected good traffic versus bad traffic, so we could proactively block it. All of these sort of generate logs, right? Either in CloudWatch or ultimately S3. So it's also important, right, that we protect these. There's a number of techniques that can be applied, even so far as to storing these in a separate AWS account. But again, versioning, secure delete, and policy-based retention is going to help you here, right? In that scenario where that user experienced an issue with their S3 data being compromised because they leaked credential information to the internet, their CloudTrail log being stored in the same account was also subject to that same event, right? So it was harder for them to sort of do incident response, right, in terms of how they respond to it without that data. Fortunately, the API retains 60 or 90 days where we were able to sort of piece the full story together. So this is key, right? So the more sort of relevant data we have as far as detecting goes, the better quality our next step, our response is going to be. So response and our recovery, right? How are we going to respond, right? So depending on the incident, there's quite a wide variety here that we could take to respond, right? So in our hypothetical, say malware incident, leveraging detective is going to help us understand, alongside guard duty and flow logs, the traffic that's coming and going. So is this still going on? What events? What do we need to do to effectively block and respond to it, right? Logs are key. Also key is retention, right? We want to capture snapshots of the disks. So we could go back and piece that story together, right? Especially if there's legal ramifications. And we could do the same, basically with memory, right? We could use third-party utilities like threat response, volatility, or recall to capture snapshots of the memory. Fortunately, because most of those logs are stored in S3, we have the ability to basically quickly query them, right? This is key. As soon as we detect an incident, we need to be able to start putting together a plan to respond to it. Having access to those logs, being able to query and correlate, leveraging something like Athena, and tell that story lets us move into sort of the next set of steps. And that's the recovery, right? So again, this is going to vary, but first and foremost, after we have captured our data, right? And one key thing here that I missed on this last slide. Logs, right? You may have retention policies. You may have retention policies that clean up snapshots, content on S3 logs. It's important that you capture all of those and store them, quote unquote, to the side, right? You don't want to inadvertently have them be cleaned up down the line by a retention policy you set and forgot about. So on the recovery side, right, we want to block access, right? So we've sort of identified that this piece of malware is doing its thing. We've blocked access to it with security groups, ACLs, what have you. We want to revert to a known good state. So the great thing about this is with workspaces, right, we can do that. We can kind of restore to the previous snapshot. We can even re-provision those users using fresh images, right? We don't necessarily want to trust what is out there as being good, right? We obviously want to figure out what the root cause is. How did this happen? What controls were missed, right? Just like our game day, we want to learn what came out of this, and we want to address it, right? And most importantly, we want to rotate our credentials, right? What we can't necessarily say for certain exactly what credentials may have been compromised, right? So rotate user passwords, rotate user accounts, and the like. Finally, measure. How did we do, right? So we did our game day exercise. We measured that. Here's our real world exercise. What are our gaps? How do we need to change things from an architecture perspective? How do we need to change things from a process perspective? And that's basically it. So, I mean, in conclusion, don't get bogged down, right, with trying to do all of this at once. Something is better than nothing, right? So iterate, right? There's, in the course of probably, 1 to 2 hours, a number of these AWS services could basically be enabled. That's already increased, the quality of your security operations, and you continue to iterate and add to that. Detective controls are just important as preventative controls, right? Without detective controls, we're guessing at how the issue came to be and how to respond to it. And then again, there's certain AWS services, Systems Manager, CloudWatch, that can be extended to your on-premise environment. So if you're running a hybrid environment, you can manage a lot of those systems in the same way. And as you saw, and as I spent a ton of time on, there's no lack of frameworks, right? So you pick and choose from the things that make the most sense. For me, I like the life cycle approach to the cybersecurity framework. It's very methodical, right? I don't necessarily want to try to recover until I have first responded to the event. Otherwise, I'm likely going to find myself responding to the event again, or detecting the event again. And that's basically it. So, I wanted to see anyone had any questions, feedback, or maybe further discussions they wanted to get into. Otherwise, thanks so much for listening. Cool. Doesn't look like we have any questions. So again, feel free to engage with us either in the Slack team, through our Meetup pages, and we'll make the recording and slide share available over the next few days. Thanks everyone for joining.
Thanks, Patrick.